Good afternoon to all. So we'll see one more topic on the HML. Okay, that is the minimum description length principle. Okay, so just they are comparing this whether HMAP is giving a shortest hypothesis or not, because we are in the search of shortest hypothesis in each and every learning algorithm that we have seen in the decision tree also, that we have seen in the neural network also. So we require shortest hypothesis. Okay, so just they are comparing our HML or HMAP with those algorithms, nothing else it is. Yes, it is also giving a shortest hypothesis. That means in number of bits. Okay, so how many bits it is going to choose for each of the hypothesis. Okay, the principle of shortest hypothesis is minimum description length principle. It is given by the interpreting the definition of HMAP. First we will have the HMAP. So this is our HMAP formula. Okay, so this is our HMAP formula. So just this is equivalently can be represented by taking the log 2 on this expression. Okay, so why log 2 I will tell you later, why only base 2. So I will take the log 2 on these. Okay, so log of this means log of this x plus log of this y. So that itself log of x plus log of y. Okay, so instead of Rmax I will take the Rmin here at that time. So negative of this will be there. So Rmin negative negative. Okay, so why we have converted the HMAP into this? Okay, so just to compare with the Shannon coding theory. Okay, just to compare with the Shannon coding theory. The Shannon coding theory tells what? It will tell this is the theory. This is what? This is a number of bits with respect to specific coding C. So some coding method. This is the number of the bits. Okay, and pi is what? It's the probability of occurrence of that message ith message, how many times the probability is there. Log of this, negative of that will give a number of the bits. This is the Shannon theory. Okay, so we can interpret this equation 1 using this Shannon theory. Okay, the Shannon theory always give a minimum number of bits. Okay, by applying this formula. Okay, we can compare that with the equation 1, our HMAP. Okay, so this first term. So this is the first term. What it is going to tell you is the description length of this h. That is the probability of that h under the sum coding. You will under the sum coding, in other words, is the size of the hypothesis h, or the description of this hypothesis h, or the probability of occurrence of that h is given by this notation. So this is directly taken by, because this notation is equal to this. So we can, in that expression, we can represent this using this notation. Okay, so that is a length of h. The number of bits required to this h is equal to this. Okay, similarly the second term can also be represented using this. Okay, the length of h. Okay, the length of this. Okay, now we can, the equation 1, so we are putting in the different notation. So instead of this term we are putting this term. So that is, will be Rmin of this plus this. The number of bits required to represent h, d of h, and the number of bits required to represent this. This equation proves that HMAP is a one with the minimum number of bits used to encode the hypothesis. So to prove that HMAP is also give the shortest hypothesis. Okay. So we are comparing that with the Shannon theory. Okay. So in other algorithm, in decision tree we require a smaller tree. In the neural network we require a small number of the bits, like that. So HMAP is also giving a small hypothesis. Okay, so just 4 or 5 marks it is going to be asked. Okay, so if you have any doubt in this,